Friends, welcome back to one day IoT workshop. And this is the most happening event in this lockdown, and this is of its own type. So friends, you might have understood the two sessions. That is the first session of IoT embedded system and second session of IoT. Now, if you see, the session started with what is microcontroller, what is microprocessor, and then we have defined what is system, then what is embedded, and then what is embedded system, and what are the different parts of embedded system. Now, after that, I have defined when this embedded system is connected to internet, it will become Internet of Things. So I have defined what is Internet of Things, who invented Internet of Things, and what are the basic components needed, and what is processor, actuator, sensor. This all things I have defined, and you have studied all this, or you have understood all this in physical terms, or other terms which are written in the presentation. Now, actually, we'll see what all these things are. So, at the end of the second session, you have seen the two hardware, that is Arduino and Raspberry Pi. So, here in this session, uh, that is a post exam session, I can say, of one day IoT workshop, which is on Arduino basics. So friends, we'll see what is Arduino, what is basics, complete hardware, how to install the software, and how to what are the different functions, and many more things. And till the end of this session, I'm assuring you that you will be getting a knowledge how to use Arduino. After this, there will be a session on interfacing, and after that interfacing, again there will be a test. So these two tests will be evaluated, that is after first two sessions, series sessions, and the next two will be almost two practical sessions. So friends, let's continue with the session. And in this session, I'll be explaining you what is Arduino, what are sensors, what are actuators, what are the functions, and how to use these functions to control my Arduino. So friends, without wasting your time, let's start. And I know you're eagerly waiting for the session, and I hope you might have enjoyed two pre-test sessions. So now, what Arduino is not, very first thing. So it is surprising, like what Arduino is not. Why such question? So Arduino is not a chip, very first thing. Second thing, it's not a PCB, that is printed circuit board. Again, there may be a question here. What is the full form of PCB? Now, it's not a company or a manufacturer. It's not a programming language. It's not a computer architecture. Then the big question comes, what is Arduino? Let's see what is Arduino. Now, Arduino is an open source hardware. It's not a microcontroller. Founded by Massimo Banzi and David Cotlis in 2005 in Avira, Italy. Now, it's a open source hardware platform. I'm quoting it. It is open source hardware platform. Open source means code is available to you. It's not necessary that open source should be free. But here open source means code is available to you, and it's a hardware platform. Till now, you might have heard open source software. This is open source hardware platform, which is easy to learn. There are a lot of libraries, and it is based on wiring language. It have its own IDE, that is integrated development environment. So, and we can write the program in the way we are writing the C language. Coding is accessible and transferable, and also its IDE is available for Mac, for Linux, and for Windows. And friends, even if you don't have the IDE install your machine, the designers have done such a facility that you can go to the site, and you can even write the code in online editor the way you are writing on your offline editor. So that's a fantastic thing about Arduino. So which processor is in Arduino? It's the processor which is used in Arduino is Atmega 328. It is 8-bit RISC architecture. RISC means reduced instruction set computer, and another are CISC, complex instruction set computers. So the processor like 8085 and 8086 are complex instruction set computers, CISC. Now friends, again this RISC and CISC may be for your question. So it's a DIP, dual inline package with 20 megahertz clock, 32 KB flash memory, and it has 1 KB of SRAM, 23 programmable IO channels, 6 10-bit ADC, that is analog to digital converters. Internal there are 3 timers, and 6 PWM, pulse width modulation. So friends, these terms like RISC, DIP, SRAM, ADC, PWM, may be for your question. So please note down the full form of it. Now, what this AVR means here? AVR means Elf Egil Bogen and Vegard Vollen. So this Elf Egil Bogen, Vegard and Risk makes AVR. So it is also known as Advanced Virtual Risk. Fine. So again, friends, this may be some questions for you. Now, what are the features of Arduino? So first, one by one, we'll take features. First, it is an open source physical computing platform, basically used for experimenting and electronics. Rather, you can say it is experiment with electronics and to develop the things. And sometimes you may get an idea to develop something, so you can do it very easily. So in this lockdown period, one fine day I was sitting, and when I was sitting, something got in my mind that why I shouldn't make some system for my uh, lockdown, or what after the lockdown. So it is being told that we have to maintain the social distancing, but it's not necessary that we can keep that distance. So what I've done, using two sensors, I have made one hardware called a social distancing hardware. Video for that is available on my channel, in which there are two sensors. One is connected at my front and one is connected at the back. And if a person comes within the 2 feet range, it will start beeping. So it's a very simple application. So you can say with using simple sensors, I've made some experiment and I've designed. So it's having a fun, and the intuition which I came in my mind, I've converted into an experiment. Second is Arduino is unique simplified programming language, and there are a lot of tutorials and libraries available on the net, so which will help you in programming. So even if you are navy or amateur in programming, or you are a fresher, if you don't know large concepts of programming, Arduino will help you, or the libraries of Arduino will help you. So it's not necessary that you should be a very professional programmer. No, if you're a fresher, it will do. And one more thing, Arduino has some IDEs in which you need not have to do programming. There are all symbols ready made. You have to just drag drop the symbols and your code will be ready. So next, when you can with Arduino, you can easily explore a lot of small scale sensors, actuators, and many more things. And definitely, there is no end to your imagination. Same way, to convert your imagination into device, there is no end. So it depends upon your thought process, how much you can think and how much you can convert your ideas into an reality. Now, why Arduino is preferred? There are a lot many things, but why I'm preferring Arduino? Very first thing, it is inexpensive. Fine. And it is a complete board. It is a complete system. Unlike my 8051 or 8085, it's not that single processor or a single controller, but it's a complete system. Second, it is cross platform. It can work with different platform. It is simpler, clear programming. It's open source extensible software and open source extensible hardware. These are the two main important features, that is open source extensible software and open source extensible hardware, are really making this more and more powerful. That's why Arduino is more preferred compared to your 8051 or 8086. So friends, let's move further and see what Arduino is. Now, apart from your normal Arduino, there are many different flavors like Arduino Uno, Leonardo, Lilypad, Mega, Nano, Mini, Pro Mini, and BT. So there are many types of Arduinos available. You have to select which is applicable or which holds good for your system to be designed. Now let's say one fine day I have to design a wearable cloth. In that I need Arduino, not like a square board which will be hanging, but I think something which I need like looks like a flower, or something which can be properly connected to my clothes and it won't look that it's a hardware. So in that case I can go for Lilypad type of hardware. So depending upon your application, suppose if you have more number of input and outputs, then you can go for such Mega. If your space required is very less, you can go for Mini or Pro Mini. And if you need intermediate, then you can go for Nano. And of course, you know, Uno is evergreen, always used and available. So let's see different flavors. One is Uno, 101, Pro, Nano, Pro Mini, and Micro. And see what are the difference in this. So compared to your Arduino, this form factors, hardwares are different. Now Pro, this USB connector is different. In this Nano, it is almost same like Uno, but again the form factor, that is the size, and its connector is different. You see the Pro Mini doesn't have any programming hardware on that, and no power supply feature. So unlike Nano doesn't have the power supply, whereas also Pro Mini doesn't have any power supply feature. So in this all 5 to 6 different flavors, Uno and Zero has the additional power supply features, where rest all are driven by the power from the computer USB. So let's see further what are the different Arduinos. Friends, yet I'm telling, if you're not yet the subscribe the channel, so please subscribe it. Follow me on the Instagram with the name Kavedia sir. Now here Kavedia sir is a single word. Same is on the Facebook also. It's an Kavedia sir. So friends, let's move further and have a close-up view of Arduino. Now on my Arduino board, there are different points or different sections. So this is my reset button. This reset button is used to restart my system. This is my USB port here. Now this USB port is doing two functions. It helps in downloading the code, so it can connect with a computer, or I can connect to a power bank, so it can be used for powering my system. Apart from that, there is a 12-bit input. There is a 12-volt input. This can be given from the adapter. So my adapter can be connected to AC mains, and this adapter will power up my Arduino. So once my programming is over, I can remove the USB cord from here, and I can connect the adapter of 12 volt, which will run my embedded system. And after that, there is a controller on the board. So it's a regulator on board, and this regulator will convert this 12 volt from here to 5 volt, on which my complete system will work. And this is the main controller, which is at Mega 328. So this was the hardware. This here it is a 6 crystal of 16 megahertz. It may be 20 megahertz also. Now next is Arduino has 14 digital IO pins. They are named from D0 to D13. So these are total 14 pins, and out of this 14, 6 pins are PWM pins, which can be pulse width modulation, on which I can change the average voltage level. So which can be used for my intensity control also. This we'll see further in the presentation. So the pins which are marked with this tiled sign, a sign which is like this, tiled. These pins are 3, 5, 6, 9, 10, 11. So only this pins can be used for PWM. And suppose if I have a sensor which are analog in nature, which will give me analog signals, then I can connect it to this A0 to A5. Now to this A0 to A5 means, when I connect a sensor to this, internally there is 10-bit ADC, and this 10-bit ADC, what it will do, it will convert this analog signal to digital, and it will be given to controller for processing. And other than that, in the power supply section, it has a plus 5 volt supply, 3.3 volt supply. Now 3.3 volt supply can be used by sensors like DHT, and it can be used by Bluetooth modules. And also it has a reset pin, a 5 volt supply. So 5 volt can be used for my different subsystems which I'm connecting to this Arduino. So friends, I hope what are all the things on the Arduino board is clear to you. On Arduino board, there is a reset button. Then after reset button, there is a USB port, and after USB port, there is a 12 volt input. Then there is a power supply section with 3.3 volts and 5 volts. There are 6 analog inputs and 14 digital IOs, and out of this 14 digital IOs, 6 are PWM. Now coming to the power supply section, I can power up my Arduino in different ways. So I can use my adapter. This adapter will go to the 12 volt input. So adapter is connected here, and I can connect a USB connector here. Now this USB connector can be connected with the power bank, and also can be connected to PC. So it can be powered up in two ways, from the PC as well as the power bank. And again, this power connector can also be powered up in two ways. I can connect a AC adapter of 12 volts, and I can connect a battery of 9 volts also. But my board is always safer because there is a built-in regulator of 5 volts. So whether I'm giving the input from the adapter, or if I'm giving the input from the battery, it will convert it into 5 volts, and then only it will drive the Arduino. So these are the different ways I can give power to my Arduino board. But while programming, it is always recommended that you give the power which is from USB, so it can do the programming as well as drive my board also. So friends, I hope this much is clear. Till this point, what we have seen is what is Arduino, what Arduino is not, and who invented, when invented, and what is the purpose, and what are the different boards, and how I can power up the Arduino. I hope this much is clear. So let's move further with the session. So the next session is, you have understood the Arduino board. Now let's go for installation. So for installation, you have to go to the site called as arduino.cc. And once you go to this site called as arduino.cc, I have three ways of installation. The first, I can install with Windows installer. Second, I can take Windows zip file. And third, I can use an app which can be used for Windows 8 or above. So I have these three ways, and definitely there is a fourth way also. That is, I can do coding online. So there is an online editor also available. So I can install Arduino IDE by installer. So I have to download that installer. So I will click this first option here. By clicking this first option, I'll get a installer. So I have to click that, the IDE will get installed. Second is a zip file. Now in this case, in my second, I have to download the zip file. I have to unzip it, and after unzipping, I have to rename the folder with the name Arduino, and in that there is an exe file called as arduino.exe. And the third is Windows app. But whatever may be the things, whether you are installing with installer or installing with the zip or with an app, in all the three cases, you have to run arduino.exe. Once you run that arduino.exe, you will get the Arduino IDE, and here IDE stands for Integrated Development Environment. So friends, again here there may be a question, what are the different ways to program an Arduino? So let's move further. Let's see one of the zip installation. When I go with the zip installation, I'll download a file whose name is Arduino Nightly Windows Zip. So the file will be downloaded. Once the file is downloaded, in the download folder it will be available. Now in download folder, you'll copy that file in another folder, and what you will do is you will extract that file. After extracting the file, you have to rename the folder. I've told you, you have to rename the folder. So folder name should be Arduino. Now once that folder name is given, you can see this arduino.exe. This is an application file. The moment you double click this, it will launch an Arduino IDE. So this is my first look to Arduino IDE. So friends, in this Arduino IDE, I have at the top, which is called as the title bar. Then there is a menu bar. There is a button bar. This is a programming area. This is something for the status, and this is for error messages. So these are the different sections. What are the different sections? There is a title bar. There is a menu bar. There is a button bar. This is a program area where you can write the program. Here there is a status, and finally here there are error code, which is also called as program notification area. So friends, I need not have to tell now. This will be some more questions, or this will give you some more questions for your test. So let's move further. What I'll do, I'll launch my ID. The moment my ID is launched, there will be a first new, second open. So new is to create a new file, and open is to open the existing program. Now one more thing friends, in Arduino, the program is called as sketch, not the program, neither script nor module. It is called as sketch. Now once your ID is installed, once your Arduino board is connected, after connecting the board, I have to see for two things, that I have to go to tools and I have to check which board you are using. So if you are using Arduino Uno, I have to select Arduino Uno, or whatever type of board you are using, Leonardo, Explora, Micro, Mini, Pro Mini, Nano, whatever you are using, you have to select from this list. So my board is to be selected. That's the first point. After selecting the board, I have to set the port, to which port my Arduino is connected. So again, you go to tools menu, go to serial port and select the COM port. But if it's only showing COM, means Arduino is not yet connected. It should show COM3 along with Arduino Genino or Arduino. If that Arduino word is missing, then it is not connected to the port. So again, remove the pin, connect it properly, and then again check. So let's move further with the options. The major options on the button bar is A, that is to check whether my code is proper or not. So it will give you compilation or verification, or it is used for compilation and verification. And if there is error, it will show compilation and errors. before verification. So these errors will be notified in the bottom area, which is called as program notification area or error message area. The next is to upload a program. So the second button with the arrow sign pointing towards right is for uploading the code. Now suppose if you forget to compile or verify the code, your Arduino IDE will never forget that. So before uploading the program, every time it compiles, verifies, and then only it uploads the IDE, uploads the code, and the notification that compiling done, uploading done, and progress is shown on the bar which is in between your program area and error message area. There is a small gray bar in which this status is defined. Now coming to the next, that is the button. This is called as to create a new sketch. This is to open the sketch and this is to save the sketch. And finally here, this is for serial monitor. Now serial monitor is a tool which will help in communication between your PC and the Arduino. I can send the data to Arduino and Arduino can send data back to PC. So this two-way communication can be controlled with serial monitor. So I hope friends this total menu is clear to you. First is to check the compilation error. Second is to upload. Third is to create a new sketch. Fourth is to open the existing example, and fifth here, that is E, is your saving the sketch. And finally F1 is for serial monitor. So that is for the serial monitor. Let's see further. Something when I turn on my IDE with a new sketch, I get some code in which there are two functions. One is called as setup function and other is called as loop function. Now friends, this is called as bare minimum code. If I just go to sketch and compile, it will get compiled. So this is a minimum code which is needed for Arduino IDE to check. So in setup function, I'll write all the things which are needed only once. That is like initializing the variables, setting the pins, initializing the serial communication, or initializing the LCD, or initializing the sensors. All these things which is initialization, setting the initial values, declaring the variables are done in setup, but only once it will be executed. So that is the first function which is called as setup. Coming to the next, that is called as loop. Now loop is a function which will move infinite times. When my system is on till the system is off, this loop function is going on. That's why my embedded system is always running. Now take an example of your TV or air conditioner. When I switch it off with remote, it actually doesn't get switched off. It goes into low power mode and it is waiting for some activity from the remote control. The moment you press on, again it will read the data and turn it on. So the reading function is always done in a loop and it is waiting for the sensor to get the information. So this was the bare minimum code. Now let's see how to use the built-in code available. So suppose if you have got a fresh Arduino from the market and you have to check whether it's working or not, and you don't know what the programming is, so this will help you definitely in testing the board. So friends, what you have to do is you have to go to file menu. From file menu you will go to examples. From examples you will select basic, and from basic you will select blink. Prior to that, there is a bare minimum code which I have already explained you. You will select blink. Now what that blink does, we'll see. So let's say the blink, and blink, there is a, in a setup there is a pin mode function. There is LED built in. This is pin number 13. So on pin number 13 there is a LED built in. So this can be used, and this output says my output says my pin is in the output mode. So a minimum one line code in setup which will define pin number 13 as output. Now coming to the loop, in loop there is one function called as digital write, and I'm writing high to it. So this high means to LED pin I'm writing high, so the LED will glow. It will wait for 1 second of delay, that is 1000 milliseconds, and again I'm putting it low. Low means I'm putting it off, and again I'm waiting for delay. So this high and low, what it will do, it will turn on the LED for 1 second, switch it off, 1 second on, 1 second off. So in this way I can connect, I can test my Arduino. So what you have to do, take a Arduino, connect it to the port, turn on the IDE. After turning on the IDE, you do the board selection and the port selection. After that, go to file. After going to file, you go to examples. From examples, you go to basic, and from basic, you will select the blink. And very simple job you have to do, go to sketch and say upload. It will do compilation, verification, and in upload that particular code. And once the code is uploaded, you will see LED blinking on the board with a delay of 1 second on pin number 13. So this is very simple way to check my Arduino. Now let's see what are the different functions. So from 5 to 6 functions minimum are needed to understand. So out of that, first is digital read, second is digital write, the next is pin mode, analog read, analog write, and delay. So these are some functions which are needed for my programming. So by the next session, this will be the functions we'll be using to read the data from the sensor, to output the data to the actuators, controlling the intensity. So basically by next session, we'll be moving with these functions only. So friends, again here, I need not have to inform you, this may be some few questions. So let's say what are output devices? So output device is LED, buzzer, and relay. So these are the three output device. So LED is for indication, visual indication, buzzer is for audible indication, and relay is for controlling the high voltage applications. Now coming to input devices. Now input devices, I have sensors, I have switch, and two pins which I'm connecting this sensors or this output or input devices. I have to define that pin as either input or output, and that is defined with the function called as pin mode. So if the pin mode is input, that particular pin which is defined at the place of pin will be taken as an input pin, and if it is the pin mode is output, then that particular pin will be output pin. So for connecting sensors and switch, I have to make the pin input, and for connecting LED, buzzer, and relay, I have to make the pin as output. I hope the pin mode function is clear. Now let's say what is digital read. Now what digital read does, it will help in reading the data from the sensor. So I have to just define pin number to which the switch or the sensor is connected. So you can see here, this is a switch, this is a sensor, and using this digital read pin, I have to just define the pin number and it will give me the sensor status. It may be a high value or a low value. Fine. The next function is digital write. Now I've told you this write function is to write, and always we write the data to output devices and read the data from the input devices. So input devices like sensor and switches will give the data, whereas relays, buzzer, and LED will take the data. So giving the output is digital write and taking the input is digital read. So I can connect LED, I can connect buzzer, and I can connect relay to this output pins. So this to pin which I'm connecting these devices, I'll define here, and the value I'll define here. So I can have either high or low. If I give high, LED will glow, buzzer will buzz, and if motor is connected, motor will rotate, and definitely the device which is connected to relay will get turned on. So the value may be high or the value may be low. So the next function is analog read. Now digital read will read the data from the digital sensor which may have the value called as 1 or 0. But then analog read will read all the sensor values which are connected to pin number A0 to A6. This is A0 to A6. To these sensors, I'll connect the analog sensors, and the value is internally connected to digital. I've told you it has 10-bit ADC. To read this digital value, I have a function called as analog read, and I have to define the pin. The pin may be A0 to A5. So one of the example given here is your LM35, which is a temperature sensor. The temperature sensor will be given to analog input. This analog input will be converted into digital, and digital input will be given to the processor internally but not externally. So I've told you in the features somewhere that for Arduino, the programming control is not possible in session 2, where I've told you why not to use Arduino. In that I've told you it has not precise control on assembly part. Now the next function is analog write. Now for analog write, the first thing comes in mind that where is the analog pin? So sorry friends, there is no analog pins, but there are PWM pins which are called as pulse width modulation pins. So the pins which are marked with the name called as PWM or the tiled sign, I've told you the sign, tiled sign, those are PWM pins. Now PWM means pulse width modulation. So if you want to see, if you want to have a more details of what is pulse width modulation is, on my channel there is a video called as intensity control. So see that video, you will understand what do you mean by the word pulse width modulation. So friends, here I can control the intensity. Now how I can control the intensity? So I'll define the pin number here. Now this pin number can be 3, 5, 6, 9, 10, 11. Only this pins, not the other pins. And this value can be any 8-bit value which vary between 0 to 255. So when I give this value 0 to 255, its average voltage is generated and given output on these pins. That's why it's called as analog, right? Because it will have 256 different voltage levels depending on the value 0 or 255. 0 means totally off, 255 means totally on. Now if I take the LED, so 0 means it will be off, and 255 means it is a brighter LED, that is we are getting in digital write with value 1, and we can write 128, which will give you the 50% brightness. So in this way, by giving different values, I can control different analog write, or different intensity, or different speed, or different audio tones. So friends, if you want to see how audio tones are generated with analog write, you can see my video on audio tone generation. So let's move further. So till this point, I hope these functions are clear to you. We have seen what is digital write, pin mode, digital read, analog write, and analog read. So once fast recap: digital read is to read from the sensor, digital write is to write to the output device. In both the cases, the value will be high or low. Coming to the next, that is analog read. It will take data from analog pins A0 to A5, and those values will be of 10-bit converted value of ADC. And analog write will have 256 different level of values to generate different voltage on analog write pin. But again, there is a thing for analog write: pin number 5, 3, 5, 6, 9, 10, 11 can only be used. So I hope this function called as pin mode, digital read, digital write, analog read, and analog writes are clear to you. So we'll move further. So fine. So till this point it is clear. Now I have to write the sketch. I have told you, after writing the sketch, I have to do compilation with compile and verify button. Once compiling is done, I have to upload it, and after uploading you can see the output. This is what exactly we have done for testing our Arduino board. So what we did, first we have written the sketch, then we have done the settings of port as well as the board, and then after that I have compiled the code, verified the code, made it error free. After that I have uploaded, and after uploading I can see LED blinking on pin number 13. I hope friends this much is clear to you. So this was about the Arduino basics, its sensors, input devices, and output devices. So friends, I hope you are enjoying this session, and you might have understood like what is Arduino and its basic. Friends, 30, 35, or 40 minutes is the too long, low time, or the less time to understand the Arduino. But then I've tried my best to give you best output in the minimum time span.